Hello, this video is on solving systems of inequalities. And I'm going to double underline inequalities because we just did a couple weeks on solving systems of equations. Systems that had two equations. So there is a relationship between systems of inequalities and systems of equations. First of all, we're going to have two inequalities in each system, just like we had two equations in each system of equations. So when we were doing systems of equations, we were given two equations that sometimes look like this. And now you're going to see a system of inequalities. So instead of equal signs, you will see inequalities. Less than or equal to in this case, greater than or equal to in the second one. Now to show you the difference between a system of inequalities and systems of equations, first I will quickly sketch the system of equations for comparison. So the graph of the first equation has a y-intercept of -1, a slope of 1/2, so I'm just roughly sketching this. It'll look something like this. The second equation has a y-intercept of 3 and a slope of -3, so it's very steep with a negative slope, so something like this. So in a system of equations, the solution is, as you know, the point of intersection. That is the solution. It's going to be an ordered pair. Now, a system of inequalities has solutions as well, but it's not going to be the point of intersection. It's going to be something else. The good news is you're still going to graph these two lines just as you did for the system of equations. So that part of the process is exactly the same. There's first line. And there's a second line. But here's where the solving the system of inequalities diverges from what you would do here. So in a system of equations, you would use substitution or elimination or even determinants in some cases to find the solution x comma y. You don't have to do that here. So that's good news. That's a lot of steps that you don't have to do at all, because we are not looking for this point now. Instead, we're looking for a region of points. If you look at the two lines have now separated this space into 4 regions. I'm going to call this the northern region, the one that is bordered by these two lines, these two rays. I'm going to call this east. This is the region bordered by these two. This is south. And this is west. And the solution to this system of inequalities is going to be one of those 4 regions. And when I determine which of the 4 regions it is, I'm going to shade it in. That's how I show graphically what the solution is. It's the shaded region. So why is it a region of points? Because y is less than or equal to 1/2 x minus 1 is telling me that there are a bunch of points that are less than or equal to 1/2 x minus 1. There are a lot of y values that are less than 1/2 x at 1/2 x minus 1. Where are these y values? Well, remember which line this inequality is represented by. It's this line, right? That's how we graphed this line. We got it from here. Now I look at the inequality. It says less than or equal to. If y is less than or equal to this line, that means it's below. So if you see less than or equal to, that means below. Shade below. So imagine this whole region below this line shaded. Everything on the coordinate system shaded below. Okay, keep that in your mind. The second one says greater than or equal to. Greater than or equal to means above. Greater than or equal to this line. That would be the steep line with the negative slope. I need to shade above this line. Now, for a negative slope line, what does above mean? Well, it has a slope to it. It has a lean to it. So above would be here. Below would be here. For a positive slope line, above is here. And below is here. Okay? So since I need to shade above this line, that means I need to shade here. Okay, now I'm going to use a pencil and shade the two regions. The first one, which was this, and then the second one, this. Now, I'm not going to keep all of this shading because this is a system. So I need the region that satisfies both of these inequalities. The region that satisfies both of these inequalities is the region that was shaded twice, east. So in the end, I keep the shading in the eastern region and I get rid of the stuff in the north and the stuff in the south. This is the final solution to my inequality. Now, if you have a good visualization talent, you may not have to use a pencil and shade two regions and then erase the parts that don't overlap. That's fine. You may not have to do what I just did. But if you like doing that, then shade for the first one, shade for the second one, and figure out what is the overlapping part that is common to both, and then get rid of the part that isn't common. Okay, second example. Now to simplify matters, I have used the same slopes and the same y-intercepts. The only thing I changed was the inequality here for the first one. So that means I can use the same lines I used before. But the shading will be different. Okay, so I'll use a pencil. For the first one, I want to shade above this time, not below. Above because it says greater than. So that'll be here. and this one is still above. This one didn't change. So that's here. So in the end, I'm going to shade this. And I'm going to get rid of west and east. However, there's something wrong here because this inequality says greater than. It does not say greater than or equal to. So there's a difference there. So we need to know, what does it mean when it says greater than, equal to versus just greater than? Well, greater than or equal to means show me all the points that are above the line as well as all the points are equal to the line. All the points that are equal to the line are the points on the line, that are physically on the line. A line is made up of points. So these points are included when it says greater than or equal to. However, when the inequality just says greater than, that means I want all the points above the line, but not the points that are on the line. Not the points that are on the line. So I need a way to communicate to the reader that in the graph, I am not including the points on the line. If I draw the line like this, for greater than or equal to, then I need to find a different way to draw the line for greater than. Otherwise, it will be unclear. It'll be ambiguous to the reader if I'm including the points on the line or not including the points on the line. So the line that has just the greater than should have been drawn differently. So by convention, we've decided that when you don't want to include the points on the line in your solution, you just use a dotted line. The second one still had greater than or equal to, so that one will still be a solid line. And the shading is the same as what I did here. So this is the actual solution for this system. Okay, so remember, dotted line for less than or greater than. Use solid line for less than or equal to or greater than or equal to. Okay, last example. Y is less than 5 and x is greater than or equal to 1. Okay, first of all, remember, any line of the form y equals k is horizontal. So this is a horizontal line. And any line of the form x equals k is a vertical line. So we've got a horizontal line and a vertical line. The horizontal line will go through the y-axis at 5, and it will be a dotted line. The vertical line will go through the x-axis at 1, and it will be solid. Okay, now I decide where to shade. The horizontal line, I'm going to shade below it. That's here. The vertical line, it says greater than or equal to, I usually shade above, right, for greater than or equal to. However, A vertical line doesn't have an above or below because it doesn't have a slope like these lines. So what's above, what's below? So this is where I have to temporarily forget about the above and below because there is no above and below. And I have to think in terms of the x direction. The x direction is either left or right, right? The x-axis, it goes left and right. The greater numbers are on the right, the lesser numbers are on the left. So when I see greater than or equal to from the x point of view, I have to think in terms of right and left, not above and below. Greater than means to the right. Less than means to the left. So in this case, I'm going to shade to the right of 1. So that's here. So in the end, this region will remain shaded. Okay, so there is your video on graphing systems of inequalities.